starting from this pseudocode, we're going to learn how to translate our algorithm into a Python code. So let's open a new notebook, and the first thing to do is to insert all the data. Let us define our first variable, the inflow rate qin. We can set it to 1. As you can see, in Python, it is not necessary to explicitly state that qin is a number, unlike what happens in other languages like C or C++. But what is the text in green? So in Python, what follows the hash sign is switched off. It is ignored by Python, and it is just a comment for us humans. So we can print qin on the screen to check its value by using print. And in brackets, we can insert a sentence like the inflow rate is, and the name of the variable. The message will be printed below this block of code when we run it pressing the play button. Now we can continue inserting all the other data, so the area of the tank, the area of the outlet, gravity, the initial water level H0, but also T, the total simulation time, and the number of time steps, and as a consequence, delta T, the length of the time step. After we run this block, all the data are set and can be used. And now we have to define the outflow rate. Do you remember that the outflow rate Qout is a function of the water level H? What we need is a block of code that can take H as an input, process it, and return the output Qout. This black box is a function, so something that can take inputs and produces output. In Python, functions begins with the keyword def, followed by the name of the function, and in brackets, the inputs. After the column, then we can write our instructions. First of all, pay attention to the formatting of this code. Note that the lines forming the body of the functions are indented, and this alignment is of extreme importance in Python. Without it, the code simply would not run. Then the keyword return is followed by the quantities given as output by the function. And in this case, we are simply computing the outflow using Torricelli's formula. But where is the square root here? In Python, with the syntax ***, we can raise a base to any power. So in this case, with the value 0.5, we are computing the square root. Going back to the big picture, now that the function has been written, we can run the block and it's ready to use. So how can we test it? Let's print its output for a chosen value, for instance, h equals 0.5. Now the value in bracket will be given as input to the function to compute the result. So by running this last block, we obtain a value of about 0.31. Now we have all the ingredients to perform our simulation. What we need is a container to store all the values of the solution, h, for the different times. So for this purpose, we need to create lists. Lists are one of the most flexible data types in Python. They are ordered containers where we can store in each, let's say, drawer different types of data like numbers, strings, or even other lists. And each element has a precise position indicated by a number starting from 0. So we need to create lists of n+1 elements. And this syntax is one of the ways to create a list of 0, for instance, to store simulation times. And then we can do the same to create a list to store h. And there, we can fill the first element with the initial water level h0. And what about all the other values? So we have a recipe to find h1 given h0, h2 given h1, and so on. So To compute h at all the other times, we need to learn how to write a loop. So a loop begins with the keyword for, and it is used to repeat a block of instructions many times. And in Python, the for loop is used to go through the elements of a list, which is usually a list of integers, to easily count the cycles. So this integer list can be created using range. For instance, here range 3 creates a list of integers ranging from 0 up to 2. So for n in range 3 means that n will take values 0, 1, 2. After the column, once again, we can write our instruction and once again pay attention to the alignment, to the indentation. So for instance, we can print the value of n. So now in the first iteration, we will print n equal to 0, then n equal to 1, and finally n equal to 2. So going back to our problem, according to our algorithm, we need to find n values of h, and the first one is already given. So range big N. And for a generic iteration, we know hn, and we need to find hn plus 1. So first of all, what we can do is to compute the water level change in a time step depending on inflow, outflow, time step, and area. Then we can add this delta to the old value of h, obtaining the new one, and we can store this new value in the list in the right place. And finally, we can save the corresponding time, which is n plus 1 times the delta t. Now, by simply running this short block of code, we are performing a very large number of operations, and at the end, we will have all the discrete values of h. And finally, we can plot the solution. The functions we need are contained in a Python module called matplotlib, and in particular, in its submodule pyplot. So before we use it, we need to import it, and for short, we can rename it plt. Then we can call the method plot with inputs times and age corresponding to the x-axis and y-axis of our plot. And finally, show will produce a picture. We can, for instance, add a grid on top of the axis using the method grid, and add axis labels, so times on the horizontal axis and h on the vertical one. And now let's have a look at the solution we computed. Notice how initially it grows very rapidly, but after some time it reaches an almost constant value. This happens because the outflow is initially very small, but then it grows with the water level h until it finally matches the inflow and we reach an equilibrium. And now it's your turn.